chapter is heights and distances. The applications of trigonometry for standard 10. So here the question is, the lower window of a house is at a height of 2 meter above the ground and its upper window is 4 meter vertically above the lower window. At a certain instant, the angles of elevation of a balloon from these windows are observed to be 60 degrees and 30 degrees respectively. Find the height of the balloon above the ground. So let us let this be the house, and let this be one window and the other window is like this. So the lower window is at a height of 2 meters above the ground. So this is 2 meters and the upper window is 4 meter above the lower window. So this is 4. So let's write this as A, B and C. At a certain instant, the angle of elevation of a balloon from these windows are observed to be 60 degrees and 30 degrees. So from here, draw parallel line. So the balloon is here. So the balloon is here at, this is 60 degrees. So from here, again we will draw one parallel line. So from here to here, this is 30 degrees and this is 60 degrees. And so now this is 4, this is 2. Now we do not know this height, so let this height be x. So A, B, C, let this be P, Q, R and S. Now we have to find the height of the balloon above the ground. Now we have to find the full height. PS is what we have to find. So it is given AB equal to 2 meters, BC is equal to 4 meters. We have to find PS. So first in triangle SQB, tan 60 is equal to SQ by BQ. So this will become BQ is equal to, so root 3, so BQ is equal to SQ will be 4 plus x. 4 plus x, this is tan 60 is root 3, so root 3. So this is first equation. Now in triangle SRC, tan 30 is equal to then RS by RC. So RS is equal to, sorry, RC is equal to RS, RC is equal to RSS X by tan 30 is 1 by root 3. So we will write RC is equal to X root 3. So now we will equate it. This is actually tan 30 is 1 by root 3. 1 by root 3 is equal to RS is X by RC. That is why RC is equal to X root 3. This is equation 2. Now we know RC is equal to BQ. RC is equal to BQ. Therefore, 4 plus x by root 3 is equal to x root 3. So, root 3 cross multiplying, so it becomes 3x. So, 3x minus x is 2x is equal to 4. So, x is equal to 2. Now, we have to find the height of the balloon. Therefore, height is equal to PS. So, 2 plus 4 plus 2. So, 8 meters. So, therefore, height of the balloon is equal to 8 meters. A boy is standing on the ground and flying a kite with 100 meters of string at an elevation of 30 degrees. So, we'll first draw the figure. So, the kite is here. So, here he is at an angle of 100 meters of string. So, this string length is 100 meters and elevation of 30 degrees. So, when you draw the figure, write down all the data, whatever possible in the figure itself, so that it will be easy for you to write down the ratios and do the calculations also. Another boy is standing on the roof of a 10-meter high building and is flying his kite at an angle of elevation of 45 degrees. Both the boys are on opposite sides of both the kites. So here there is another building over here. So the boy is standing on the building. This is the building. It is 10 meters. The building height is 10 meters. And his angle of elevation is 45 degrees. And find the length of the string that the second boy must have so that the two kites meet. So another, so it is like this. His kite is also so it has to meet this kite. So this will be 45 degrees. So the angle of elevation is always along the ground, or a line parallel to the ground, horizontal. So now we have to find the length of the string of the second boy. So AC is what we have to find. AP is given as 100 and CQ is also given as 10 meters. Now in triangle ABP, sine 30 is equal. So now here we will be taking sine because this length of the string is given, that is hypotenuse we have got. So sine 30 is what we have to take. So sine 30 is equal to AB by AP. So according to what the data is given, we have to take the ratio, whether it's sine or tan or cos. So now sine 30 is equal to half is equal to AB by AP is 100. So from this you get AB is equal to 50 meters. Now in triangle ACD, in triangle ACD, again sine 45 is equal to AD by AC. So we get 1 by root 2 is equal to so we need AD, so we know AB, and this is 10 we know, so AD is equal to 40 by AC. So we can write down here AD is equal to AB minus DB. So AC is equal to 40 root 2. So that is the length of the string the other boy must have. Of the second boy. 40 root 2 meters. A round balloon of radius r, subtends an angle alpha at the eye of the observer, while the angle of elevation of its center is beta. So this is slightly different from their normal problems. So the radius of the balloon is r. It subtends an angle alpha at the eye of the observer, while the angle of elevation of its center is beta. So this is the center of the balloon. So this angle will be beta. That is angle LPO. Angle LPO is equal to beta, and it subtends an angle alpha. So that means the full APB will be alpha. So this full angle will be alpha. Angle APB is equal to alpha. So we know that then this will be alpha by 2 and this will be alpha by 2. You already proved all this in the chapter circles, because these are tangents, and then you can prove these two triangles are congruent, and therefore these two angles are equal. Now we have to prove the height of the center of the balloon is r sine beta cosecant alpha by 2. Now we have to prove OL from the center to this is the height of the balloon. This is OL is so and so. So OL is equal to, you have to prove that OL is equal to r sine beta cosecant alpha by 2. So we can write angle OPB is equal to angle OPA is equal to alpha by 2, and OA is equal to the radius r. So now we will take sine alpha by 2, that is PLO in triangle PLO. Sorry. So in triangle PLO, we will have sine beta is equal to OL by OP. So we get OL, let us write OL is equal to OP into sine beta. So let it equation 1. Now we'll consider the triangle OAP. triangle OAP. Now we know the radius is perpendicular to the tangent. So this is 90. So this is 90. You can write OA perpendicular to AP. Then we'll take sine alpha by 2. So both are equal. This is alpha by 2. This is alpha by 2. So sine alpha by 2 is equal to OAO by OP. So you get AO is R by OP. So R is equal to OP sine alpha by 2. We need OP. So we will write down OP as OP is equal to R by sine alpha by 2. So this is equal to R. 1 by sine theta is cosecant theta. So cosecant alpha by 2. So we'll substitute this in 1. Substituting 2 in 1. We get OL, because we have to find the height OL. So OL is equal to OP sine beta, that is equal to R cosecant alpha by 2 sine beta. That's what we have to find.